All right, so in this video we're going to talk about the informal definition of a limit and the ways limits don't exist. So we'll start with our definition of a limit. So if the outputs of a function, f of x, approach a value L as the inputs x approach C, then we say the limit as x goes to C of f of x equals L. This is sometimes read limit of f of x as x approaches C is L. Okay, so let's look at an example of this. So let's say we have the following function that's described by a graph. And function looks like this. It starts at 4, goes down to 2, and then down to 1. At 1 it hops up to 2, and then it goes back down like this, and then like that. All right, let me just organize things a little bit here. Okay, and let's call this just example 1 for simplicity. Okay, so now we're going to compute the limit as x goes to 1 of this function, call this function f, limit as x goes to 2 of this function, and limit as x goes to 3 of this function. Okay, so we'll start with limit as x goes to 1. So what we want to do is we want to look at inputs that are close to 1, and we want to look at the corresponding outputs. So we can be close to 1 in two ways. We can be above 1 or below 1. And as we get close to 1, the outputs, the fx values, approach 2. So this is going to be 2. And you might say, okay, well, why don't I just use the function output at 1, which is 2, to find the limit? And that works for this, this point at 1. But if we're looking at a different point, say we're looking at this point 2, what the function does at 2 is output 2. But it's clear that if we look at the points near 2, they're getting function outputs that are close to 1. Close to 1. So the limit as x goes to 2 of this function is 1. The outputs near 2 are 1, even though the function output at 2 is 2. Okay, let's do this last one. So we're going to look at an input that is below 3, and you'll see that its output is close to 3. If we look at an input that is greater than 3, but close to 3, its output is going to be near 4. So we have 3 and 4 as numbers that we're approaching, and 3 is not equal to 4. We're not approaching a single L as we get close to 3. So for this third limit, we say the limit does not exist. Does not exist. Because we're not approaching a single value as we put inputs in this function close to 3. Okay, let's do another example. So in this example, we're going to estimate a limit numerically. So we're going to take the limit as x goes to 2 of x squared plus x minus 6 over x minus 2 using values, inputs. Let's do inputs. It's more precise. Inputs close to 2. Okay. So here's my input. We're going to do 1.9, we're going to do 1.99, and we're going to do 1.99. We're getting closer and closer to 2 with our inputs, and we're going to see what this function, which is x squared plus x minus 6 over x minus 2, outputs at those values. And if If we use a calculator, we'll see that if we put 1.9 in for x into this function, we'll get out 4.9. If we put in 1.99, we'll get out 4.99. And if we put 1.999, we're going to get out 4.999. So as the inputs approach 2, the outputs appear to be approaching 5. So this suggests that the limit as x goes to 2 of this function is 5. And later on, we'll see how to do this in an algebraic fashion. You'll see that we can factor the numerator and denominator and figure this out without doing any computations with the table. All right, one more example. So in this example, we want to ask, why does the limit as x goes to 2 of x squared minus 2x plus 1 over x squared minus 4 not exist? Okay, so I'm telling you it doesn't exist, and we want to see why. So we're going to do something similar to what we did in the last problem. We're going to put in values that are close to 2. This time I'm going to do values that are close to 2 but are bigger than 2. So 2.1, 2.01, 2.001, and 2.0001. If you put in 1.99, you'd see something similar. And we're going to look at the approximate outputs of this function. So if we put in 2.1, we're going to get approximately 2.95. 2.95. If we put in 2.01, we'll get approximately 25.4. If we put in 2.001, we'll get approximately 250. And then the last input results in 2.50 times 10 to the 3, or 2500. So it appears as x is approaching 2, the inputs are approaching 2, the outputs are growing larger and larger. Another way of saying this is they are going to infinity. And we can see this if we draw the graph of this function. So let me draw the graph of this function for you. So it has an asymptote at 2. And it kind of comes in like this and then goes down. And then comes in from the right like this and goes up. So you can see that as we're putting inputs in that are close to 2, we're getting outputs that get larger and larger. And as we get really close to 2, we're getting outputs that are growing in an unbounded fashion. Outputs go to infinity as the inputs go to 2. So we say the limit as x goes to 2 of this x squared minus 2x plus 1 over x squared minus 4 does not exist because the function goes to infinity. It's actually going to negative infinity and positive infinity. But it goes to infinity from the right. And so it does not exist. There's not a number that it's going to. It's blowing up. You can also say it blows up. All right, I hope you found this video useful.